Welcome back. We're going to continue solving systems of linear equations. Today's lesson 4.2 covers the elimination method, also known as the addition method. The book calls it the addition method. As you see, we are either going to add or subtract certain parts to certain systems to eliminate one of the variables. Now, our first example, 3x minus 5y equals negative 9 and 4x plus 5y equals 23 is perfectly set up for the elimination method. We have them, I like to write them in standard form if they're not written in standard form already. ax plus by equals c, so we have what I call vertical alignment. Our x's are vertically aligned, so are the y variables, so are the equal signs, and so are the constants. In this case, I'm just going to draw a line. There are different methods and different strategies and actually different ways to do these problems. Here is my preferred method. I want literally to have opposite y's or opposite x's. And then I'm going to add these two lines together. It's a pretty cool little strategy and a pretty cool little method. 3x plus 4x equals 7x. Negative 5y plus 5y cancels out to 0. Bring down your equal sign. Negative 9 plus 23 equals 14. So if 7x equals 14, divide both sides by 7, x equals 2. Now your choice, pick, remember, solutions. Any of the solutions for any of these systems, system solutions, are ordered pairs. Therefore, when you do this mess here, you haven't finished the problem. In fact, all you've done is half the problem. All we know is one of our variables. We know the x value or the x coordinate of our solution. Your choice, pick one of these two. Some might choose this because the numbers look smaller. I'm going to choose this equation. It does not matter which one you use. 4 times 2 or 8 plus 5y equals 23. Why did I choose the second equation to solve for y? Just because it's all positive numbers. Even though they might be a tiny bit bigger, 4x is a little bit bigger than 3x, and 23 is definitely bigger than negative 9. They're all positive numbers. But again, it's your choice. It does not matter which one you use. You should come up with the same answer either way. Subtract 8 from both sides. 5y equals 15. Therefore, y equals 3. Now, if the directions don't say solve the system and check, or show a formal check, then you don't have to actually check your work for extra credit or for full credit rather. All you have to do is do a mental check. This is kind of for your well-being. Let me put a 2 in here. Put a 2 in here for x. I'm going to get a 6. Let me put a 3 in here. Put a 3 in here for y. I get minus 15. And 6 minus 15, does that equal negative 9? It does equal negative 9, so we're good to go. This is the only point on the entire Cartesian plane where these two lines intersect. Now, I know it didn't ask for this, but I would like to get the practice. What type of system is this? This is called an independent system or an independent solution. How do we know that? Because it only has one answer. All right, so let's take a look at the second problem. Make sure I'm still here in frame. All right. Solve 2x minus 3y equals negative 13 and 5x minus 12y equals negative 46. All right, now it's going to start getting a little more college algebraic in the sense that they're not just going to be set up like this. This is kind of like an instant dinner. Actually, this is like DoorDash or Uber Eats. It's brought to the door. You just got to answer the door and then open up your food and eat it. Here you have to do a little bit of prep work. What's the prep work? Well, I don't have opposite x's. I don't have opposite y's. But If I multiplied this first equation by a -4, let's see what that's going to result in. And notice the way I organized my work. Okay, I bracketed this the entire first equation. I put a -4 out front, and then I drew this little type of arrow so that way I could say -4 times 2x is -8x. -4 times -3 is +12y. We're going to take a look at that sign in just a minute. And -4 times -13 is +52. Now, I'm just going to bring this guy straight over. The second equation, I do like a single line. I'm just bringing them straight over. 5x minus 12y equals -46. And then I get in the habit of drawing a line underneath them, and let's adding these up. This becomes -3x. This cancels out. There's our elimination. And that's going to be equal to 52 minus 46 is equal to +6. If a -3x equals 6, dividing both sides by -3, x equals -2. Once again, come to the original two equations. Pick one of these. Pick this equation here or this equation here to plug this in for x and then come up with our y value. I think I'm going to use this equation, the first one. Come off to the side over here, like this. And here's what I'm going to end up with. I'm going to end up with a -4. Where did that -4 come from? -2 times +2. Right here. So -4 minus 3y equals -13. Add 4 to both sides. -3y equals -9. Divide both sides by -3y equals +3. Now, here's where you don't have to formally show anything, but I would encourage you, any math student that is worth anything in this world would know to do this. Let's take this value of -2, put it here. Let's take this value of +3, put it here, and let's see what that gives us. All right, -2 times 5 is -10. -12 times 3 is -36. Does that equal -46? It does. You don't have to check it into this green equation because we actually use the green equation to come up with that answer. You can if you want, but it's redundant and unnecessary. So let's just write our answer as ordered pairs. Now remember, the formal way to write it is to use braces, then parentheses. I don't get that formal. Here's where I do get my tiniest bit of lackadaisical or a little bit lenient, and I just say I need the ordered pair -2, 3. Order matters. Not numeric order, alphabetical order. X value, then Y value. That's pretty self-explanatory, except for some students still don't get it. And again, this would be an independent system, by the way. Just want to throw this out there at y'all if y'all are kind of in a rush to go through this video. You know you can speed it up. You can listen to it at a faster speed, like at 1.25 or 1.5 or 1.75 or even 2. Now my voice will sound very funny, kind of like Alvin and the Chipmunks, but hey, get you what you need to do. Example 1 was all set up for us. Example 2 was we had to do a little bit of work to one of the equations. Example 3, we're taking this step by step, further and further, doing a little bit more work. We are going to, let me see, I'm going to have to actually multiply both equations by something for me to eliminate one of my variables. Let's multiply the first equation by 3, which will give us -6x plus 9y equals 18. And the second equation will in turn be measured by the number 2, which will give us See how I organize it with the certain arrows? If I'm actually doing a multiplication to come up with an equivalent, a different yet equivalent equation, I use this kind of arrow. If I'm just bringing it over, bring it over, bring it over, I use a single type of arrow. Anyhow, back to this problem. 2 times 3x is 6x, 2 times minus 5y is minus 10y, and 2 times negative 11 is negative 22. And what to do, what to do? Draw a line underneath them, add them up, mark out the variables that get eliminated, and add the rest. 9y minus 10y is negative y, and 18 plus negative 22 is equal to negative 4. If a negative y equals a negative 4, then a positive y equals a positive 4. You can either multiply or divide both sides of that equation by negative 1, or just logically understand. If the opposite of y is negative 4, then regular y equals positive 4. Now remember, this is not the entire answer, it's only the y coordinate. So if you're writing down your variables, or if you're writing down your ordered pairs rather, make sure I'm still on frame there, yeah. Then what you would do is bring that 4 over here in the y spot. Alright, don't want to confuse you too much if I don't have to. Now, what do? Take the value you just got and plug it into one of the two equations that were your original equations. I'm going to plug it into, what am I looking for? I already know y, so I'm looking for x. Do I want to find a negative 2x, or would I rather find a 3x? In my opinion, the way I feel today, I'd rather find a 3x, a positive 3x. So I'm going to use the second equation to get the rest of my answer. And what am I going to say? I'm going to say 3x. Put a 4 in here for y. 5 times 4 is 20, so minus 20 equals negative 11. Add 20 to both sides. 3x equals 9, therefore x equals 3 as well. Now, I will bring this 3 and put it in place of x. If you can't tell, elimination is my favorite method of solving systems. It's kind of fun. I like to get rid of stuff. It's just very clean and organized. I'm going to use the other equation that I did not use to find out my x value, and I'm just going to plug my x's and y's in there to see if I get a true statement or not. Negative 2 times positive 3 equals negative 6. Positive 4 times positive 3 equals positive 12. Is that equal to 6? Negative 6 plus 12 is equal to 6, so it all works out. All right. Example 4. Solve. 4y equals 5x plus 7 and negative 4y equals negative 5x plus 2. What I wanted to talk to you about here, every problem so far has been in standard form with the exception of this equation here, because that should not have been a negative. There is no absolute rule that says they have to be in standard form. It's just super convenient if they are in standard form, because then you have the vertical alignment. X is above x's, y is above y's, equals above equals, and constants above constants. That makes it very easy to organize and eliminate or cancel. Now, if we make sure all the problems are given to us this way, or if we kind of rearrange it till they look that way, we're good to go. But the most important thing that you need over anything else is this phrase, what I keep calling vertical alignment. What is vertical alignment? Well, one final time, vertical alignment happens whenever you have your like terms, y's, x's, constants, even those equal signs, directly, vertically, one on top of the other. Do I have vertical alignment here? Yes, I do. So I don't need to rewrite this or move anything. I do not need to manipulate these equations yet. And I hopefully wouldn't have to manipulate them at all to be able to move forward with this. Once you have vertical alignment, draw a line, add up. Oh, I'm ready to add these up because at least one of my variables will be canceled out because I have exact opposites. Now, you notice what we've been doing every single time is we're adding these two equations. That's where the book gets the word, the addition method. All right. 4y plus negative 4y equals 0. That doesn't just go away and not needed to write. If that's the only thing left on one side of the equation, you need to bring that down. 0 equals, oh, look what we have here. 5x plus a negative 5x. We have another 0. And then we have 7 plus 2 equals 9. Uh-oh. Did we do something wrong? No, we didn't. This happens sometimes. All the variables go away and we are left with a false statement. So what do we do when we have a false statement? I'm going to stop here for about 5 seconds reflection. This is non-negotiable. This is absolutely, positively, from this step forward, here's what you have to do. And if you don't, you will not get credit for the problem. At least not full credit. No, it sounds better if you like to do this. You will not get credit for the problem if you do not do this. You've done all the work, but then you have not told me the answer. And that shows me that you are not paying attention right now, or you don't know how to write the answer, or you think that, hey, we got to get this cleared up right now. Just because inside of your brain you know what it means does not mean that everyone else is going to understand what you mean. Maybe your best friend might, maybe your family members might, maybe some of your teachers might. But this is why we write it a certain way. It's called a standard way of writing the answers. Don't confuse that with standard form. Let me use a different word. You know the word universal? It's accepted, understood, and used all over the world, or the universe for that matter. What are we going to do with this? Once you have a false statement, that means, well, it literally means, by the way, the lines are parallel. The lines are parallel in this case because they never intersect. The lines, this line and this line, will never intersect. We have two parallel lines that never intersect. If they never intersect, then we never have a solution. So how do you write that? It's very simple. Null set or empty set. And if it asks for the type of system or solution, it's called an inconsistent system solution. Good one, Dad. Good one. Example 5. Get back in frame. All right, 3 more problems and we'll be done. Call it a day. This needs to be cleaned up a little bit. I have y equals, here's what we want to solve. Y equals 3x minus 4. And then we have this guy here. I don't know where he came out of the blue. Let's try a rewrite on him. Let's try saying minus 2 on both sides. And then let's combine these terms, these like terms. So if we do that, we're going to end up with y equals 5x minus 2x is 3x. Minus 2 equals minus 4. Well, look at what we have from what we have right here to what we have at the very beginning. Y equals 3x minus 4. Technically, you can multiply one of these by a negative 1. Technically, you can, let's say this, multiply by negative 1. And then this here would become either one. Let's take this green one and multiply it by -1. That's going to become a negative y equals -3x plus 4. And then when you add them together, you're going to get 0 equals 0 plus 0, or 0 equals 0. Let's get away from the red because it's not wrong. Let's go towards some Poway green and say this is true. Now, here's what we notice. If they're the same exact equation, you could have actually stopped there and said, hey, if these are the same exact equation, then they are collinear. If they are collinear, then there's going to be an infinite amount of solutions, but we do not write. Do not write all real numbers, nor infinitely many solutions. Neither of those are the correct answers. What are the correct answers? The correct answer is this. Open brace the set of ordered pairs x comma y such that your pick. You get to pick one of these two equations, either the nice simple first equation or the complicated messy ugly second equation, not to judge there. Let us pick y equals 3x minus 4 as the equation I write here, and close this brace and box up our solution. This is the new solution that students have a little more difficulty remembering. And if they ever asked what type of solution is this, it is a dependent solution. What does it depend on? The solutions depend on satisfying that equation. As long as it satisfies that equation, then it will satisfy the second equation. It will satisfy both equations, and that's what we're looking for. Where are they equal? All right, let's deal with one problem with the fraction, one problem with the decimal, and call it a day. Let's start off with this problem here. 1/2 x minus 2/3 y equals 7. Think of a number that would get rid of the divided by 2 and the divided by 3. What is our least common denominator, at least for the first equation? It should be the number 6. So let's multiply this entire equation by 6 and bring its answer right here. 6 times 1/2 x equals 3x. Half of 6. Minus 6 times 2/3, well 6 times 2 is 12, divided by 3 is 4, or 6 divided by 3 is 2, times 2 is 4, minus 4y equals 42. Let's do the exact same thing, but this time let's do it with, let me rephrase that. We're going to do the exact same thing. We're going to do the exact same strategy, but this time we're going to be looking at the second equation, and that is second equation. If we multiply it by a 6, we won't get rid of this 4 on bottom. I need the LCD of the second equation, and the least common denominator of that second equation is 12. So I'm going to multiply the entire second equation by 12. Now, what I'm doing right now is a very quick and modified version of hockey sticks that I showed you before. It's actually called, I think the book, your old books used to call it Fraction Busters, whatever. Let me see. If I multiply this second equation by 12, I could say 12 times 2 is 24, divided by 3 is 8, as in 8x, minus, or I could say, instead of saying 12 times 3, then divided by 4, you can actually work that in reverse. You could say 12 divided by 4. That's what I call simplify before you multiply, and that's the way I do all my work. Let's make the numbers simple before we make them multiplied. 12 divided by 4 is 3. 3 times the 3 on top, or the negative 3 on top, is negative 9y. And that equals 12 times 11 is equal to 121. Now, no more fractions, no more denominators, no more mess. what I have to choose from here, yeah, this is actually like a big boy and a big girl problem. It ain't baby little easy ones where it's all set up for you. You have a decision to make. Are we going to try to eliminate the x's or the y's? In this case, I always try to eliminate the smaller variables. If I do this, let's see. Let's multiply first equation by a -8. That's going to give us negative 24x plus 32y equals 336. Multiply the second equation by a +3. How am I getting these numbers? Randomly, magically, mysteriously? Well, I'm actually looking for a quote-unquote least common factor of 3 and 8. And what number can they both be divided into, or what number can they both be divided into? And that number is 24. The smallest number I can think that they both go into is 24. Why did I pick a -8 here and a +3 down here? Well, it doesn't really matter where the negative or positive went, but I just wanted to make sure this happened right here at this next step. What is 3 times 8x? 24x. Do you see those two opposites there? They will get eliminated. And then I can go on and solve for y. 3 times -9y is -27y. And 3 times 121 is 363. Come over here to these two green equations, draw a line, and add them up. Bye-bye birdie, that becomes 0. 0x or 0. 32y plus -27y is the same thing as 32y minus 27y, or 5y, equals oh yeah, don't forget your negative signs right here. -8 times 42 is equal to a negative. Now, excuse me for about half a second. Come off to the side here. I need to make sure my math is right because I just don't remember these numbers. They're looking a little ugly to me. I thought all my numbers were pretty. 8, 42. Okay, you're 1, 3, 3, 6. That one's right. 12 times 11 is 12 and 12. Oh yeah, there's my first mistake. So sorry. 12 times 11. 12 times 11 is actually 132. Where did I get 121 from? Oh, I did 11 times 11. So here's my first mistake. Whew. This should be 132 and then times 3. 132 times 3 is equal to 396. 396. Now this smells so much better. Why? Because I'm going to add these two numbers up. 396 minus 336. Sorry if you had to use your little eraser, go back and make corrections, but hey, better do corrections on notes and homework than instead of a test. Sorry. 396 minus 336 is simply the number 60. Now we have a pretty number again. Divide both sides by 5 and y equals 12. I guess that's what happens when you don't have coffee, at least me, early in the morning, and I don't have any notes in front of me. I'm doing this all off the top of my head. I usually have last year's notes or last trimester's notes just to confirm that I'm making sure my little arithmetic is right. What am I going to do? Usually I ask you to take this value and to plug it back into an original equation. These original equations are a little messy. I'm going to trust that the rest of my math is okay, and I'm actually going to use one of these, either blue or red equation. Let me see, which one has smaller numbers? The blue one. I'm going to bring this 3x minus 4y down. this equation here is going to be used. 3x minus 4 times 12 is 48 equals 42. Add 48 to both sides. 3x equals 90. Therefore, x equals 30. First answer, second answer, as far as my ordered pair is concerned. The answer to this problem here is x is 30 and y is 12. That's the point on the Cartesian plane where these two messy lines will intersect. Now, tedious work? Absolutely tedious. But you're only going to have one or two that has decimals or fractions like that. Last problem, and then we'll be done. Call it a day. Hopefully this one has 0 mistakes from the East Loss Department. Let's see. I have 0.005x or 500ths x plus 7/10 y equals 40. I already have a problem with that. Let me multiply that by 100 and write my answer over here. 100 times this simply becomes a 5x. 100 times this becomes plus 70y. And 100 times this becomes 4,000. If you need help on multiplying by tens, hundreds, thousands, or any base 10, we can do that in another lesson, but I just want to jump right into this. I'm also going to multiply all of this to get rid of that decimal by a 10. And that's going to become 10x plus 4y equals 1200. All right. Multiply this new equation by a -2, and I'm going to actually bring the results down here. Negative 10x minus 140y equals minus 8,000. I better not try to do these in my head completely. I better at least do some scratch work. This one can be done in the head. That becomes 0x or 0. We don't need it. 4y minus 140y is negative 136y. And quick math. I know I'm going to subtract these two, even though we said to add. Why am I subtracting? Because the signs are different. A positive number plus a negative number is really subtraction. Which one looks to be bigger, the 1200 or the negative 8,000? Even though the positive is bigger than that, this is much further away from 0. So this appears to be the bigger number. Its answer will be a negative. Here's the fastest way I do 8,000 minus 1,200. What's 8,000 minus 1,000? 7,000. What's 7,000 minus 200? It's 6,800. You know what to do now, and I think we're going to need a calculator. Divide both sides by a negative 136. That means y is equal to, do not have it right now. I need to grab a little calculator. Let me go get help from my little daughter. Hoopster, are you there? Divide 6,800 by 136. Let's try this out, see where it gives us. I don't know if it's going to get me anywhere in that neighborhood. Nope. $6,800 divided by 136. 50, thank you. Y equals 50. I knew I picked numbers that were going to look beautiful. Again, usually take the answer that you got here and plug it usually into the originals. You can if you want. They're a lot easier to handle than those fractions would have been up there. But you also have this choice. You know what? I'm going to use this one right here. You could have also used either of these two equations to get your x value. I'm going to use this equation here. Why? Because it tells me exactly what x is going to equal in 10 seconds or less. X plus, What's 0.4 times 50? It's the same thing as 4 times 5, which is 20. So if x plus 20 equals 120, x equals 100. And now it's coming all back to me now. I do remember that was our solution. So write your ordered pair as the ordered pair 100, 50. What type of system was this? This was independent. If you don't believe, get a calculator, or some of my scientists or some of my superstars out there are just going to use their brains. Put 100 in here for x, put a 50 in here for y. We can do that real quick. What's 100 times 0.05x? We already know that's going to be a 5 right there. If I put a 100 right here for x, I'm going to get a 5 right there. Let's put a 50 right here then. And for y, what's 0.7 times 50? It's the same thing as 7 times 5. 7 times 5 is 35. What's 5 plus 35? It equals 40. Get it? Got it good? Hope so. I hope y'all have a great day. We'll see you hopefully, quote unquote, virtually in person tomorrow.